Hi, welcome to another session. So in previous sessions, we looked at different variable types, the int, strings, we looked at lists, we looked at tuples. We also went on to look at dictionaries. And we said in the next session, we're going to look at control structures. Control structure is another concept, an important concept in computer programming. However, for the purpose of this lecture, I'm not going to bore you with the nitty-gritties. I'm going to just speak to what we're going to learn today. So at the end of this session, what you should understand at the end of this session is how to write a basic if command, also a loop. So we're going to use a basic for loop. There are other types of loops. I'm going to start you off with one and going to task you to do more research to pick up on other types of loops. Okay, so let's jump into it. Conditional statements. This is an example I typically use because I feel almost everything, if not everything, in life generally is predicated on fulfillment of certain conditions or otherwise. Okay, so what I'm trying to say, one of the reasons why you can view this course is because certain conditions have been met. One of such conditions is you have a device. Okay, you have a device that is powered. So if you didn't have a device, you won't if there's no device either in front of you, perhaps a display or a personal device, you won't have access to this course. If that device is not powered, so yes, the device could be there, but if it's not turned on, it's just blank, it's just off like this, you can't do anything. So it's not enough to have a device, it needs to be powered, it needs to be turned on. Okay, and you see that there are the layers of conditions to be met just so you can access this course, amongst other things. you know these are different conditions, and in the Python programming language, just as several other languages, there are ways of expressing these conditions. So the way of just controlling to say, if this condition is met, let this particular action take its course. So if you have a device, if the device is turned on and then you're on a particular point, perhaps a page or an app installed in the device, then you can access this. Of course, you also need internet access, to be able to access this. So it goes on and on. Now to bring it in here, before I even bring it in here, one of such words we use in our everyday discourse is the word if. So putting this scenario together, I would say if you have a device, you can access this course. If the device is powered, if the device also has access to the internet, I wanted to add if you're subscribed to the channel. All right, but that's on the side. Okay, you already are. So all of these conditions need to be met, and they are predicated on that word if. Okay, they're predicated on that word if. And just to demonstrate that quickly here, I'm just going to say to create a variable. So I have these variables, these names here, and I'm going to say value for this variable. I'm going to put it in as fee. Okay, so let's say fee, and we're setting fee to 100. Okay, we're setting fee to 100, and now I want to check what's the value for fee. So I can say if fee, right? Now if that's keyword. So the next thing now is the expression. Okay, so I'm supposed to teach you this in this setting. The way you express this, I just want to increase the zoom level so you can see it better. I'm going to backspace on all of this. Is you use the word if first. Now next to the word if is the expression. Okay, like the variable or the value which you want to test. So in our case here was if you have a device, no device in my hands. If I have a device, then what do we want to check? Right? So if I have a device, then perhaps I can access the course. Okay, that is if I have a device. So that's the first condition to be checked for, right? So in this case, I'm just saying if, I'm going to say if fee, right? is equal to, I'm going to say 120. Now this is the expression I'm trying to check the condition. So you put a colon to it and then you can hit enter. By default, language just indents that piece of code for you. So you can see that my cursor already is a bit indented from where this original if is. So it's just pushed it a little bit outward to the right. Okay, that's to make you know that every other um, thing is like a block of code. If this condition is met, that should be run. Okay, so if fee is equal to 120, I could just say print fee is equal to 120. Okay, I have that just coming in there. Fee is 120. Okay, and I could end this here. This is a basic if, and I just execute. I could end this here. Oh, sorry. I'm saying this. Okay. I think I'm going to just reduce this zoom off a bit. So if fee is 120, print 120. Now fee, as we set it in here, is not 120. We set it at 100. Now this is a case of being static. Now if I still, just for illustrative purposes to express, I could now say else. Okay, so you could also say else. Now else in here, so we're saying the colon again. Else I can now go into say print fee is not 120, or I'll just say fee is a different value. Fee is a different value. So I execute this. Um, so sorry, I think I'm supposed to indent it this way. So yes, so the else is also supposed to be alongside same line, right? With the if. So now I'm saying that this execution in here. So all of this, we're focusing on this here. Fee is a different value. So we're saying if fee is equal to 120, print fee is equal to 120. That's if this condition, this expression that is checking for is met. If not, with this else statement, we're saying print fee is a different value. Now I'm just going to back up a bit here to explain a little bit of this equal to symbols that you're saying. I bet it's a bit confusing. You're seeing one equal to symbol here, and then you're seeing another equal to symbol here. What's going on? Now the equal to symbol, as you've seen it, when it's used, just a single one is used. We use it to assign a value, to a variable, basically to a variable. Okay, so here we're assigning fee is equal to 100. But when you see the equal to symbol used twice, just close together, in some instances it's even used twice. There you're not assigning. There you're trying to check if this is true, if a condition is true, if actually fee is equal to 120 in this instance. So if you wanted to check for a name, if the name there is Belema, so even you're checking to see that there is a match, that's when you don't use the single equal to. All right, so when I just left that a single equal to symbol there, you saw the error that it threw back at me. So when you're trying to check for a match, that's when we use the double equal to symbol. You could also use triple, and let's see. Okay, in this instance, triple is not going to flow. I'm just going to stick to the double. But the triple also comes in handy for other instances. Let's just stick with the double for this particular bit here. All right, so you're saying this bit here. Now, beyond if and else, sometimes you may want to put another layer to it. Okay, so the else could be the last thing. Perhaps you want to say, if it's not 120, what if it's a different value? Okay, so I'm just going to come in here to add another, for it to do another check, and that's else if. Okay, and else if. So I'm just going to say else if. Now if fee, we're not checking, is equal to, so let me not say equal to, what should I say equal to? Yeah, I just leave that equal to, is equal to 100. what should it do? It should print here that fee is actually 100. Okay, so now if I execute this and we look closely, fee is still set to 100, and so we have this value, this return here, fee is actually 100. If we were to just change this here to add different one, fee is now 1001, and we execute, we should see a different a response here to say fee is a different value. That's because fee is not equal to 120, and then it moves to the lower block, the next block, which is the next condition you set for it to say is fee equal to 100. This condition is actually not met, so it skips it and moves to the next condition. Say, oh, there's no condition, you're just saying finally else print fee is a different value. Now the beauty of this is you could have more than one else if, okay, or else if. So you could have more to check if you have more different conditions that you want to keep evaluating or checking for. You could also do that. Okay, I hope this is clear. Where it's not clear, replay the video, use the comment section, to drop your comments, questions on areas where you need clarity on, and I'll be happy to jump in on it. Okay, so having said that, I'm just going to come off in here. And the next bit I want to speak about now is loops. Okay, so still on control structure, well, we just said condition. So, oh, you have a device, if the device is present there, is it powered on? If it's powered on, what's the next thing that should be done? Okay, internet access, all of these things need to be met for you to be able to access this course and do other things, with your device. I'm sure you're already doing such. That's for conditionals. Now, for loop is basically you're telling the computer that I want you to execute a particular set of instructions or a block of code a defined number of times. Sometimes this number of times could be based on a condition or a static number of times. So you're saying like, hey, do this 4 times or go over this again until this condition is met. So there are different kinds of loops. So we have the basic for loop, we have for in loop, we have while loops, and also variants of the while loops. I'm just going to go with one of the most common ones, which is a for in loop. Okay, so I'm jumping up from the for to the for in loop. So for the for in loop, to illustrate that now, I'm going to use something we had learned, right? So I'm going to put something to your test. Now let's create a list. So I'm just going, what are we going to call this list now? List of numbers. So that's what we're going to call it, list of numbers. Okay, list of numbers. Voila, I have list of numbers. But I also want more numbers. So yes, I want it to 10. Should we stop at 10? Okay, let's just stop at 10. Now we'll stop at 10, and I want this for this command here. I want to write to say for number, right, in list of numbers. I know you're seeing all of this IntelliSense here, but we're not running with this IntelliSense right here. So I'm just going to say for numbers, I want it to move through these items in this list. Okay, through the items in this list here. Now, when it does that, what do I want it to at the end of the day? That's why I'm not using this yet. Okay, what I want it to do for me now is print the value, print number, right? I want it to print number for every, sorry, I want it to print the number, okay, and return it, to us. So every time I want it to print the number, and I'm going to escape a new character here, a new line character, and I'm also going to say, let's close this print command here, and I want it to also say this is the current number So now let's execute this. Okay, and I see I have an error saying I forgot the comma. So let's just go through this. Yes, indeed I forgot the comma in my print statement there. So I execute, and now it's executed, and I'm just going to scroll down. So you see that it's iterating through it. Okay, so so you can see it's returning. This is the number. This is the current number in the list one. This is the current number in the list two. This is the current number in list three, four, five, six, till it got to the last point, and then it terminated. Now, explanation of what you were seeing in here. The four. Okay, so it's just like an instruction. You recall from previous session when I gave an instance of my younger years having to go run errands, for my mom, and you could also relate with some of that bit there. So that's like an instruction to say, oh, to the computer now, for you're initiating the command, okay, the instruction that you're passing to the computer. For now, go do this, right? Now, the number, this word here or variable here is just an iterator. So you can think of it as a variable for the loop. All right. We also have to use the terms. You're in the space now, so we also have to use the terms. So this number in here, it could be anything. I think I could call it. I could just call it. Some persons just use a single letter for it, so it could just be merely that. And if we execute this again, it will still return just that. So you can see it still returns just that. So it doesn't really matter in terms of what you call it in here. The important thing for you to note is you have to specify the iterator or the loop variable, and then you're saying in. So now observe the coloration of the words as well. The in now is now an important command, right? Just as the for, because you're now specifying, say, for n, that's for n in list of numbers. So the list of numbers we saw, we created it in here, is a list. So you're saying for n to go through this list, that's the iteration to iterate. So it goes through it the first time, and then it executes. It goes through the list again, right? Because it has done the first iteration here, and then it executes. So it's this second iteration. That's why it keeps coming back to say this. Do you understand this? Okay. Um, some of this may feel a bit hazy at first. I would advise you slow it down, replay the video, no rush, no panic, and you're going to get a hang of it. Um, I'm just going to bamboozle you with just one more thing, okay? Just one more thing. I planned on cracking a joke. Sometimes we do say something. I think it was coming from a popular preacher or an infamous preacher, and he says, "Can I shock you?" There's a response to that. If you don't know the response, you do some research. But if you do know the response, please put it in the comment section so some person can see it. Can I shock you? I'm just going to bamboozle you with one little adjustment to this, and which is what IntelliSense was basically trying to show earlier. Okay, and what do I want to do here? I want to embed the if. I want to embed the if command in this for loop here. So I'm just going to come out of this now to write another for loop. So yeah, I'm going to say for, let me just say k, right? For k in, I'm going to use our variable list of numbers, right? For k in list of numbers, and for each iteration, I'm going to ask it to check. Now, what I want it to check for me is if k, I want to check for even numbers, even and odd numbers, all right? So if k divided by, so this is one way of, I'm just trying to, if k divided by 2, right? Sorry, equal to 0. I'm going to explain this, what this means here. Okay, what this means here now. The percentage symbol in programming language such as this here, it is interpreted as a modulus. Let's just scratch the technical jargons. Okay, It's used to basically perform a division operation and then return the remainder. So you recall from your very early arithmetic, you're trying to perform a division. So you have a number 4 and it's to be divided by 2. So 4 divided by 2 is what? 2. Is there a remainder? There isn't, right? So excuse me, that's what we're checking for here now. So for each iteration, so we're just checking for that number. If it's divided by 2, what's the remainder? The remainder. I don't know why I keep saying remainder. Okay, the remainder. Now, you're familiar at this point with the double equal to symbol, right? Correct. So the double equal to symbol, we're saying that check for when 2 divides the value of k if there's a remainder. So if the remainder is 0, that means nothing, no value there. If the remainder is 0, it means that it's an even number, right? Because for all even numbers are divisible by 2. You do recall this from early arithmetic, or you have to go back to class. All right, that was just on a lighter note. So that's what this is coming to check here. So I'm just going to um, run that to say print is an even number. Else, okay, so if it's not an even number, it's an odd number. So I'm just going to say if it's an odd number, I want you to say it's an odd number and actually show me that odd number, right? So are you ready for this? Let's execute and see it in operation. So I'm just going to drag this up so we can see this. So this is the iteration, and based on that condition you can see, so it says 1 is an odd number, yes, because 1 divided by 2, we're going to have some remainders. Yeah, I said it right this time. We're going to have some remainders because it's not a perfect divisor. Okay, but however, 2 divided by 2, right, you don't have any remainder. 3 divided by 2, we definitely do. 4 divided by 2, we do not have a remainder. And so it just goes on and on. So what do I want you to do from this? I want you to try this out, play this again, and where it's not clear after you've played it 3 times. Sorry, let me just take that again. After you've looked through this particular model 3 times and it's not clear, let's use the terminology. If you have looked through this model 3 times and it's not clear, print, which is type areas where it's not clear, and I'll be happy to jump in to explain that to you. I'm sure other members of the community would also love to see and share their opinions where necessary, where they can. Thank you for tuning in. I'm really proud that you stayed up until this point. I'm looking forward to your comments. And when you're done with that, you just navigate to the next section where we'll be talking about functions. Bye for now.